Hey there, and welcome to Ontario Math. And it's been a while, but we're going to kick right into it by getting into a tutorial about fractions, and especially equivalent fractions. Now, fractions, for some reason, get a bum rap. No one seems to like to do fractions, but really, fractions can be your friend. Just give it a shot. So why do we need to know anything about equivalent fractions? Well, it's important to know that a fraction can be written differently but mean the same amount. So it doesn't have to be the exact same fraction to be the same amount. We'll get into it. Let's take a look here. So let's talk about the idea of how a fraction is even written first before we get into too much. So we write a fraction, well, it's split into two things. It's split into a numerator, which is a number at the top, and a denominator, which is a number at the bottom. The number at the bottom, the denominator, always refers to the amount of items or things in total. So in this case, here's our circle or pi. It's split into two pieces in total, 1, 2. So my denominator is 2. And we're talking about 1, we're counting one piece there, so our numerator is 1. So our fraction is 1 over 2, or 1/2. Okay, so over here, I always start with my denominator. I always like to count up how many in total. So 1, 2, 3, 4 pieces in total, and our numerator is, well, 1, 2, right? So it's 2 over 4, or 2 quarters. In this case, count them up, 1, 2, 3, 4, 5, 6, 7, 8. Our denominator is 8, and how many are we talking about in total? Well, we're talking about 1, 2, 3, 4 pieces, okay? So this is 4 over 8. Now these are all equivalent fractions, and what equivalent means is equal, or the same. And we can tell by in the picture, I mean if we take a look here, 1/2, right, is the same amount shaded in total here, as in 2 quarters, which is still the same amount shaded in total here, which is 4 over 8. So 1/2 is equivalent to 2 quarters, and it's also equivalent to 4/8. They mean the same, they're just written using different numbers here. Okay, we could have also figured out equivalent fractions by using multiplication. So I'll just write out our equivalent fractions again here, and we'll just use multiplication actually now to show that they're equivalent. What you have to do is pretty easy. You just have to find a number that you can multiply both the numerator and the denominator by. So in this case, we multiplied them both by 2. 1 times 2 equals 2, and 2 times 2 equals 4, so they're equivalent, as long as you multiply them both by the same number. In this case, we multiplied 1 times 4, which gave our numerator 4, and 2, again, it has to be the same number. I can't change it to 3 or 6. 2 times 4 equals 8. So these are all equivalent. So let's try it out using maybe a third. So let's write an equivalent fraction for a third. This time let's choose a different number. Maybe we can multiply both by, let's pick a number, maybe 8. It doesn't really matter as long as we remember to multiply both of them by the same number. So 1 times 8 equals 8. 3 times 8 equals 24, and these are equivalent. 1/3 is equivalent to 8 over 24. It could also go the opposite direction, actually. Say you had 4 over 12. You could actually divide instead. So 4, the only problem is you have to know what they both divide by. So they're both even numbers, so let's just start with 2. So we could also do 4 divided by 2 equals 2. 12 divided by 2 equals 6. And these are also equivalent, as long as we divide by the same number. So the idea is you either have to multiply both of them, numerator and denominator, by the same number, or divide it by the same number. You can choose any number. I mean, we could have even chosen for 1/5. We could choose like times 50. And it'll still work. 1 times 50 is 50. 5 times 50 is 250. So there you go. Equivalent fractions. Just remember to multiply both the numerator and the denominator by the same number.